All right, so we're prepping for our STAAR with review, continual review. So I'd ask the girls to read about Gretchen. And before we go to questions, we always check out our T-charts, our tables. Table starts with a T, which is what these are, T-charts. And I'd ask the students, what do square, triangle, and rectangle represent? And it would be Gretchen's figure. And then these numerals represent the side links, and then these are the perimeter. So girls, read the question. So we want the mistake, if any, she made. Well, I would ask the kids to look at A, B, C, and tell me what all three are about. And that's right, they're all about the rim-rimmeter. Where is the rim-rimmeter? That's right, it's all the way around. And we add the sides together to write the unit down. Perimeter. I'd ask them for a square and a rectangle. If it's a quadrilateral, I'd show them on the STAAR chart, or ask them that perimeter's formula is 2 lengths plus 2 widths. And a big thing is if you don't see it, draw it. So we've got a triangle, a square, and a rectangle. What do we know about the square? It's 4, 4, 4, and 4. The rectangle, 8, 9, 6, and then 10, 10, 6, 6. So this says the rectangle's perimeter should be 22 yards. I'd make the kids do this. Perimeter. Perimeter. 2 lengths, 20. 2 widths, 12. 20 plus 12 is 36 what? 36 yards. It said the perimeter should be 22 yards. Is that true? No. The perimeter of the square should be 12. 4 plus 4 plus 4 plus 4. 4 plus 4 is 8 plus another 4. So the rim-rimmeter all the way around should be 16. So should it be 12? No. The perimeter of the triangle should be 23. Well, 8 plus 9, that's right, 17, plus 6. I know 6 plus 6, that's right, is 12. 7 is one more, so 13. So the perimeter should be 23 yards. This says it should be 23. Is that true? Yes. What did she write? 22. So what was her mistake? Right here, the perimeter should be 23, not 22. So that makes me wonder what I did here. Oh, I did 0 plus 2 is 6. 32. See, that was right. That was right, but this one's wrong. So this is her mistake. All right, then I'd ask the whole class to read. And I'd ask them, how do you read this? And they're probably going to say 4 times 8. Well, I would ask them, how else do we view multiplication? What does it mean? If they say repeated addition, that would be good. Then we need to repeat 8 4 times. If you say it like I've said it many times, then they should recognize that 4 times 8 is 4 groups of 8. If they understand that, this makes this easy. I want 4 groups of 8. So what are they? I would ask them what they think this is halfway. 5 is right. So 6, 7, 8. So here is one group of 8. And then I'd want 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. This is 4 groups of 8, which is 30, 31, 32. So 4 times 8 is 32, and I'd ask them to repeat that. All right, well, if 4 times 8 is 4 groups of 8, what's 8 times 4? Oh, that's 8 groups of 4. So here's 1, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And you might get them to do that. And then bounce 1, 2, 3, 4, 5, 6, 7, 8. 8 groups of 4 is also 32. And I would show them their assignment. That's what I often did. Like, their assignment looks just like the beginning of this. All right, how do we read this, girls? No, not 4 times. Yes, 4 groups of 7. Let's write that. Multiplication is repeated groups of. So I want y'all to write that. And I'd get up at this point and go check that they've written and done this while they're writing. If they misspelled it, fix it. So I want 4 groups of 7. Well, we know this is 5, so this is 6, 7. 1, 2, 3, 4, 5, 6, 7. So here's 1 group of 7, 2 groups of 7, 1, 2, 3, 4, 5, 6, 7, 3 groups of 7, 1, 2, 3, 4, 5, 6, 7, 4 groups of 7. Well, this is 25, 26, 27, 28. So 4 groups of 7, 4 times 7 is 28, and I'd get them to read it. 4 times 7 is 28. Say it again. 4 times 7 is 28. Good. All right, boys, how do we read 7 times 4? Yes, 7 groups of 4. So let's find 4s. There's a 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 24, 28. All right. So let's count groups as we jump. 1, 2, 3, 4, 5, 6, 7. 7 groups of 4 is 28. So that's what we're doing. We're using the number line to find our multiplication. All right, we're going to compare. Let's just look at the models. Which model has more shaded? The first one. All right, so this one is greater. 2 dots are greater than 1. So whatever we choose needs to show that this is greater. What is this? Is this a whole amount? How do you know it's not a whole amount? Yeah, the whole thing's not shaded. So if it represents a part, it's a fraction. Numerator says know what you're looking for. I'm looking for shaded. 1, 2, 3, 4, 5, 6. Denominator says divided into. Well, this is divided into 8. So this is 6/8. There. 1, 2, 3, 4, 5 out of 6, 7, 8. 5/8. And I would want my models labeled. There it is. All right, look at the models. Which circular model has more shaded? Right, the second one. If this one's more, the first one is less. 1 dot is less than 2. How much is shaded on the first one? 3 out of 4, 5, 6, 7, 8, 9. So this is 3/9. All right, and this one, 1, 2, 3, 4, 5 out of 6, 7, 8, 9. 5/9. Here it is. 3/9 is less than 5/9. That makes sense too, because if I knew both of my denominators were 9, 5 out of 9 is more than 3. So don't just look at the models, because for all we know on the test, there may not be models. Take a second to reason. Like both of these are 8. So if you have a pie that's cut into 8 pieces, the person who ate 6 out of 8 ate more than someone who ate 5. All right, right here. What is this? Equal. Well, let's write equivalent. And then I go ahead and write it on both of these. When something is equal, it is equivalent. And then maybe get up and go walk. Boys, were y'all good?
Yeah.
Did Hondo not want to come back?
We didn't ask him.
Oh, you should have.
I can go ask him right now.
Okay. 2 halves. Remember, if you're cut into 2, hi-ya, you're cut into half. This is half, and this is a half. But when F's become plural, we say halves. 2 halves. Well, how much of this should we shade to be equivalent to the first pie? All of it.
No.
Landon, be careful when you cross the street.
Yes.
And if he doesn't want to come across, just tell him thank you for playing. So how many did we shade? 4. Out of how many? 4. So 2 halves is equivalent to 4/4. What else are they? Boys, come here. They're also 1 whole. How do you know they're a whole? Yeah, because we shaded the whole thing. Hold his hand and look before you cross. Oh, and hold his hand. So 2 out of 2 is the whole thing. 4 out of 4 is the whole thing. So if I want a whole fraction, it would be like 7 out of good. Or 10 out of right. 10 out of 10 is the whole thing. 7 out of 7. So I'd take a minute to expand on that. 6/8. What does that mean? It means 6 shaded out of 8. How many of these? Well, first of all, what are they divided into? What's the whole divided into? Fourths. That's right. Let's add that TH on it. Not just 4. Fourths, as in 4 parts. Remember that? Fourths. 4 parts. How many of these fourths should we shade to be equal to sixth? I agree, 3. So we're going to shade in 3. Now, what if you're not sure? What if you're like, man, is this right? Or I'm not sure. Well, you could go to your multiplication table, and you've got row 3 and row 4, because I don't have one with me here. Right? Row 3 and row 4. You always go to the smaller numerator first, so 3/4. And I'd be looking if the 3's, I'm writing in my facts real quick. So 3/4. Is there a 6/8 on the same rows? Yep. 3/4 is equivalent to 6/8. It's equivalent to 9/12. It's equivalent to 12/6. They're equal because if you jump 2 3's, 3 to 3, then it's equivalent to do the same with your 8's. All right. Okay. The clock. Boys, read us about Mr. Mason. So he leaves his house at the time shown. We want the time he arrives at work. What happens first? Do you leave and get to work? Or do you get to work and then leave? Yeah, you leave. So this is the start when you leave your house. And this is when you get there. So we're going forward. First, remember, short word, shorthand, long word, longhand. So this is 7. And if you are half of a clock, good, 30 minutes. So we're starting at 7:30. And we want to move forward 45 minutes. Well, we can do this 2 ways. We could use the clock right here. Let's just jump 45 minutes by 5s. Y'all ready? 5, count with me, 10, 15, 20, 25, 30, 35, 40, 45. All right? When we went this other half, what do you know happens when we go from 7:30 to another 30 minutes? Hopefully they'll tell you it's a new hour. Good. It would have reached 8 o'clock. And then we go 5, 10, 15. So 8:15 would be the answer. Or if I know 30 plus 30 minutes, 60 minutes is an hour. I'm supposed to go 45 and I've jumped 30 only. Then I could jump 15 and 0 plus 15. Or they could jump 10, 10, 10, 10, 5. 10, 20, 30, 45. It doesn't matter. It depends on your class's level of addition. But take some time to show it. Show the jumps or show the clock movement. All right, let's read this one, class, together. All right, so what are we looking for? We're looking for total number, straws, students use, make pentagons. All right, well, if we want the total, do we want part of it or all of it? All right, total is all. That is a whole amount. So is a whole amount big or small? Big. How do we get big in math? Right, we add or we multiply. Good. Are there any key words? Yes, each. Each is a grouping word. They each get grouped together or they each get grouped apart. Well, the one that matches is multiplication. Well, total straws for what? Pentagons. How many pentagons were made? 6. Students each made a pentagon. So they didn't just make one. There were 6 kids. And each one made one out of straws. That's 1, 2, 3, 4, 5 straws. So this kid is going to use, each kid uses 5 straws to make a pentagon. Each one. So what are we seeing? Right, repeated addition. How many times? 6. So 6 groups of 5 is 30. 5, 10, 15, 20, 25, 30. All right. Read the next one first row. So they're going to read about the club, raising this at the bake sale, blah, blah. What are we looking for? We're looking for money. Club earned in May. Well, do we want some of the money they earned or all of it? Yeah, it says how much money. So we want the whole amount of money they earned in May. If you want the whole amount, should we get big or small? Right, big. What operations do we use? Add or multiply? Good. Do you see any key words for add or multiply? Good. Times. Times refers to multiply. All right, what do we know about May? May, the club raised 3 times as much at the other bake sale. Well, what was the other bake sale? $84. I want 3 times that. So 3 groups of 4 is what? 12. Carry. 3 groups of 8, which we could look right here, right? 3 8s is 21, 22, 23, 24. 3 groups of 8 is 24 plus 1, 25. All right, so D. All right, let's look at the models. Each is partitioned into equal parts. Yeah, to be a fraction, you have to be fractional, congruent, same size, same shape. Oh, Landon. All right, we want something that is true. This says 2/3, 2, and 2 out of 3 is equal to 2 out of 6. Would y'all agree that's true? No, this is way more than that. All right, so no. So now it says 1/3, right? 1/3 is less than 1/6. Is 1/3 less? And how do I know, by the way, that this says less? Because it says 1 dot is less than 2. Is 1/3 less? No. What is 1/3? It's more. All right, those aren't right. Is 1/3 and 1/6 equal size? No. All right, well, look at this one. What symbol is this? Less. Yeah, 1 dot is less than 2. This says 1/6 is less than 1/3. Is 1 out of 6 less than 1/3? Yes. Another way to do this is to cross multiply. 6 times 1 is 6. 3 times 1 is 3. 3 is less than 6. All right, we've got, what kind of graph is this? Yeah, dot plot. Why do they call it a dot plot? Because it's got dots. These are frequency graphs. So let's write the word frequency. F-R-E, Quin-C. Frequency. So if I asked y'all, how frequently do you go to the bathroom? Or how frequently do you play TV? Or how frequently do you play outside? What does frequency mean? Yeah, how often? So I want us to write that because that's what a dot plot is. A dot plot shows us frequency, how often. And then, of course, I would get up and go check while they're writing. All right, and what are all the numbers across the bottom supposed to represent? Temperatures at her house in Fahrenheit. So these are temperatures. So this is 88 degrees, 89 degrees, 90 degrees. What are the dots? It says these are the temperatures at her house, and up here it tells you it's for 2 weeks in July. What do you think the dots are? It's 88 degrees, it's 90 degrees. Well, these are 2 weeks. The dots are the days. One day it's 91 degrees, another day it's 95. 14 days equals 2 weeks because there are 7 days in a week. All right, we want to know how many more than. How many more days was the high temperature 94 degrees versus 90? If I want to know how many more are here than here, we want to know what's different. And the answer to subtraction is a difference. How many days were 94 degrees? 1, 2, 3, 4, 5. Versus how many were 90? 3. How much more is 5 than 3?
2.
2. Very good, Landon. All right. We want something to make the sentence below correct. Well, if you want it correct, you want something true. I lost my pencil. This one says the triangle should be 6, and this one says the square should be 10. Now, these are division. I don't know about y'all, but I like multiply better than I like divide. Because multiplying is forward thinking, divide is backwards, kind of like add and subtract. Sorry, I'm grabbing my pencil. So instead of divide, I'm going to think, is 6 times 8 40? Nope, 6 times 8 is 48. So if this 6 isn't right, then I don't care. Although I guess I could see, is 4 times 10 40? Yes. So that means the square should be 10. It's saying the triangle should be 5. Is 8 times 5 40?
No.
Yes, it is.
85.
8 groups of 5. So there you go.
85.
All right. So if you read this middle row about Jared. So Jared is weighing his package. If you're weighing something, let's go look at our star chart. So y'all pull out the star charts. In the middle, or it's going to be like length, width, and height. And then it's going to be the liquid capacity and volume. And then it's going to be the weight and mass section. So find the weights. And I would ask the kids, read me the units listed under weight. Yeah, you've got tons, pounds, and ounces. So, not pints and quarts, not cups, not liters. There you go. Off of the star chart, weight. So, you don't have to guess, just have to look. All right, so last row, read us about Debbie. So she practices for 20, reads for 15. We want total amount of time reading and practicing. So if I said, oh, and if I want the total, do I want some of it or all of it?
Some of it.
If you want the total amount, you want all of it. You want a whole. In math, how do you get a big whole amount?
Division.
You add. Y'all are guessing and not even listening. If you want to get big, if you want to get whole amounts, you add or you repeatedly add, which is multiply. Well, is this repeated numbers? No. It's 20 minutes and then 15. So I want to total up. This is not totaling up. This is time minus. I don't know what that is. Comparing maybe this against this. Right here, this is time plus time. And this is like backwards and forwards. I don't know what that is. So it's got to be this one. 20 plus. It says all the time is 35, but look, piano. 5, 10, 15, 20. And reading is 5, 10, 15 spaces. And 20 plus 15 is 35. There you go. All right, the last parts. We want to correctly compare these distances. First of all, which girl rode further? Mina, how do you know? Yeah, her bar is further. Look, they're both at 0, but Mina's goes further. So Mina has more. 2 dots. So this 2/3 is more. 2 dots is more than Olivia's 2/6. 2/3 is more. And I can check with cross multiplication. 3 across to 2 is 6. 6 across to 2 is 12. Yes, 12 is more than 6. All right, then we've got a pictograph. Pictograph. It says students drink 120 cartons of milk on Monday. How many cartons are represented by a picture? So they're saying that this altogether should be 120 cartons on Monday. So they're asking which one of these digits is the milk representing, 10, 20, 30, or 40. What do y'all want to try? 10s? Okay. 10, 20, 30, 40, 50, 60. 20s is like counting by 2s. Let's count by 2s. 2, 4, 6, 8, 10. Now 20s. 20, 40, 60, 80, 100, plus 20 more. 120. There it is. They counted by 20s. Those are your notes. Their assignment is very similar. I heard, by the way, that our assignments were going through an hour and a half of math, through 40 minutes of WIN, even into science and social studies. I'm not sure why, but our pacing, these should be able to get, your notes should be done in an hour. Hour 15 at most. The kids should be started on their assignments. They can have homework. They can. So y'all don't need to be losing WIN in science, social studies. Those are times you can practice more math or more reading if you need to. So don't think these kids can't have homework. I personally don't care if they use WIN for work time if they need it, but it should not be a teaching time. And like for an assignment like that activity with 12 cards, that definitely should not be going into WIN and science social studies times. If it is, we've really got an issue with our pacing, I think.
No, I can't.